I'm almost out of water. Stay hydrated. Stay golden, pony boy. Stay golden, pony boy. Come on, The Outsiders. All right, okay, all right, yeah, check it out. One of those movies that they usually show you in middle school. All right, this problem number 6. Took the liberty of writing out problem number 6, acetic acid. Acetic acid is CH3COOH. It is like one of the weak acids, the weak acid that you should know. You just know that this is a very important weak acid. Not only do I like putting it on our salad dressing, but it's very important industrially. Acetic acid. Okay, so acetic acid's weak. So that means you gotta have the arrows going in both directions. Okay. How do you know acetic acid's weak? It's not one of the strong. So it's gotta be weak. And when it breaks down, what small percentage of it breaks down will give you some hydrogen. If you have extra hydrogen floating around, you got yourself a acidic pH. Okay. So this is problem number 6. Now, I took the liberty of writing out some stuff because I knew we were going to have to do this. We need to do an ice chart. Why? Because look what the question's asking. It says calculate the concentrations of H, the acetate ion, and the acetic acid at equilibrium. If you want to calculate concentrations, or you need a concentration like we did in the last problem, we needed the concentration of hydrogen, you got to set up an ice chart. ICE. Hopefully by now, we've done enough of them at this point. 3 of them, this is our 4th one. Hopefully getting a little easier. And a lot of them look very similar. So hopefully this one will not be too bad. So I need the initial concentration though. You see, I wasn't given that. In the last problem I was told it's 0.1 molar. I'm not given that. I'm given the information to figure it out. Yeah, we gotta figure it out. So we're told we're given 0.0560 grams of acetic acid. So we have to figure out how many moles. Why? Because you need concentration. Concentration is moles per liter. So we need the moles, and we don't have that. So we have to figure it out. So we'll do a gram to mole calculation. All right, you kids have had a rough day. You sit back, relax, enjoy your, eat your root beer and drink your popcorn, and I got this for you. If we add up all of these things here in the compound, you get a mass of 60. So 1 mole of acetic acid is 60 grams of acetic acid. All right, let's divide that out, and that'll give me how many moles that I have, because the grams will cancel. And I'll put that up here on top. I already know how many liters. It told me 50 milliliters, so that's 0.05 liters that we dissolved our acetic acid. So we have the liters all ready to go. Let's get the moles. And 0.056 divided by 60 is 9.33. Yeah, 9.33. Yep. Let me just see. It's 0.05. It's 9.33. Okay, 9.33 times 10 negative 4th. Okay, small number. It's a very small number. So 9.33 times 10 to the negative 4. All right, now we're going to divide that by 0.05. So that divide 0.05. Try this at home. Try this at home. 0.0186. I'm going to go 0.019. Okay, 0.019 is my concentration of the acetic acid solution, because we were figuring out this is acetic acid solution to start. So initially, my concentration is 0.019. So that's when we start the reaction. It starts to break down, form this. Initially, I don't have any of this, but eventually we will make some of this. So we will change our concentrations by losing this, by gaining this, and by gaining this. Again, this is very familiar. So many of our ice charts are going to look like this. And then the only thing you have to be careful of a couple of ice charts ago is if you have a coefficient out in front. Remember, I don't have any coefficients, so I don't have to worry about anything in front of my x's. Okay, so 0.019 minus x. Add these 2 lines, get x. Add these 2 lines, get x. I now have the numbers ready to put in my K value expression. K for acetic acid is 1.8 times 10 to the negative 5th, I believe, but I will verify. Trust but verify. Trust but verify. Yeah, 1.8 times 10 to the negative 5. That's my K value. So I'm going to put that in. 1.8 times 10 to the negative 5. Okay, now that's my K value. Remember, K equals products over reactants. Products, x and x. By now you should know x squared, multiply those, divided by my one reactant, 0.019 minus x. We're going to do a rule of 100. This will come out to be an insignificant x. We will get rid of this x. But let's just show you, once again, how we do that. We take the initial concentration, 0.019, and you divide it by the K value. So take the initial concentration of the acid divided by its K value, and we will get second function exponent -5. We will get over 1,000, 1,055. So bigger than 100. In other words, get rid of that x and make our math and our lives much easier. Okay, cross multiply and then take the square root. That's going to happen a lot too. We're going to cross multiply and then take the square root to get rid of that x squared. So we'll cross multiply these and then take the square root, and that will give me x. So let's do 0.019 times 1.8, second function exponent -5, enter. Second function square root, second function answer. Boom, 5.85 times 10 to the -4th. 5.8, well, 5.84, oh, around it's 5.85. 5.85 times 10 to the -4th. Now that's x. What was the question even asking? I forgot. Let's look. Okay, what are the concentrations of each of these at equilibrium? It didn't ask me for pH. We could find it. We could use that H in my pH concentration. We could figure it out, but that's not what the question asked. It wants to know the concentrations of each. Well, there's my hydrogen concentration. There's my acetate ion concentration. That's easy. That's 2 of them done. One more, this one. At equilibrium, 0.019 minus x, minus this. So 0.019 minus, now that is 0.0004, so that's one more, 585. Subtract those, you will get your answer. It'll come out to be 0.018, blah, 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 blah. It doesn't change it by very much. Now, I'll go ahead and do it. It says the same blah, 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 blah. Some of you are like, is that chemistry? Blah, 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 blah. It is. Okay, minus 0.000585. I didn't need a calculator for a second. I've done that in I'm getting tired. Okay, I'm getting tired. 0.0184. 0.01841. All right, so the answer to this problem is acetate hydrogen concentrations at equilibrium are right here, 5.85 times 10 meters. To get the acetic acid, I subtract that from 0.019, and we got the answer for that, 0.018. Now, if you look at the numbers on here, they're a little bit different. This is I made this 5.8, and didn't have the 5 on it, and I made this 0.181, and that just had to do with some rounding earlier on. Don't worry about it. So we're close enough for government work. But what I do want to point out, though, I want to drag you back from the last little unit on equilibrium constants and see if this makes sense. This is a weak acid. It doesn't like to break down. Some of it will, but not much. Look at how much we have broken down. That's a very small number, much smaller than this number. This is the number at equilibrium for the acid. That's much bigger than this number here. Why? Because it doesn't like to break down. So a little of it did, but not much. And hopefully we knew that because the Kw for this is right here. This is my Kw for the acid. 1.8 times 10 to the -5. So what does that mean? Once again, it doesn't like to break down. Okay? Hopefully you can now see some of this stuff, and hopefully some of the chemistry is going, okay, I guess that kind of makes sense, hopefully. And if not, well, hopefully we'll get you there. Ah, get all itchy. itchy and sniffly today. Let's see. This video is 10 minutes. Calculate percent ionization. All right, we will do the separate video next. It'll be a short one, I promise. All right, I'll be back.